cosmology notes. That's what we're in. I think we left off on page 10. I'm going to backtrack a little bit to page 8 just to remind you where we're at. And then the guys some of you might have picked up notes on the podium over here when you came in. Did you pick up notes on the podium? Is that where you picked them up in the office? Okay. I asked the guys not to pass out the notes because we're not at the new notes yet. If you have a set of notes, if you picked them up over here and they say geology on the cover, we're not there yet. So you can just lay those aside. We'll get to them today. Famous last words. We will get to them today. But we're finishing up the cosmology section. On your cover, it'll say cosmology there. And we're on page 8. And we had been talking last week about the conclusion that the finite, finely tuned universe that the Big Bang Theory points to indicates to us that there is a transcendent, intelligent cause to our universe. So from a purely scientific point of view, some theory like intelligent design is going to be the best explanation for the fine-tuning of the laws of physics and chemistry. And so it points to not only a transcendent creator, but an intelligent and rational source to the universe. And we said that this comes as no surprise to those of us who attend church here. This is what we read in the Bible. This is what we expect to find when we look around at the universe. But there are some challenges for us who take a biblical view of creation, of how the universe came to be, and we want to look at those. And so we're going to talk about biblical cosmological model and some key challenges that it faces. So that's where we're at on page 8 of the notes, and let me flip over to that section here. In the middle of the page there, it's called Starlight and Time. And I say they're one of the most common objections to a biblical cosmology or a biblical account of creation is the general question of how do you deal with deep time? You know, we look out there and we see indications of a place that's really old. There are things going on that make us go, okay, this requires a lot of time. And it's widely held in the scientific community that the universe is somewhere around 13.8 billion years old, and that the Earth is about 4.55 billion or 4.3, depending on where you look, years old. So if those estimates are true, then that would be a problem for a biblical creation model on a number of levels. And in particular, when it comes to cosmology, because we read in the opening chapters of Genesis that God created the heavens and the earth in 6 days. And, you know, there are different textual issues people will bring up. And regardless, though, of how you then understand the chronologies given in Genesis or the genealogies in those opening chapters, the time scale since creation that the Bible appears to be presenting is really on the range of thousands of years, not billions. Even if you don't want to say a strict 6,000, we'll talk about in a little bit. A man by the name of Ussher did work with the genealogies and timelines and came up with about 6,000 years or so. The question is, how do we reconcile the evidence we find in our observations with the biblical account? And there are and have been a number of possible answers to that question, solutions presented by creationists over the years. And some of those theories have come and gone. And, well, they should, because they're not biblical doctrines, they're scientific theories. They're looking at evidence and trying to put together, well, how would this work? And that's how science works. And so they discard old theories, new and better explanations are developed as we learn more about this amazing universe that God has created. But the thing that doesn't change, as I said and alluded to, is our confidence that the description from our Creator is the right starting point. That's the place we begin to then explore and search out a better understanding of the universe that God's created. That's what we said the early scientists did as they were developing what we call modern science, right? So I had mentioned last week, if you'd come to this series, maybe you're skeptical of this biblical model that I'm promoting. You might say, well, you know, you just starting with that commitment to your creationist view hinders your search for understanding. But I just will point out throughout the series, have been and will continue to point out that that's what every scientist must do. you cannot avoid beginning from the vantage point of your worldview. You will always operate in the context of the basic assumptions you bring to your scientific endeavor. All scientists do this, including materialists and naturalists. So in a bit, we're going to talk about creationists' proposed solutions to something called the starlight problem. I list there in that heading, the starlight, time, and biblical cosmology. And there are some pretty cool ideas, pretty cool concepts being recommended currently by biblical creationists, by scientific creationists. And we'll get to those. But first I want to describe some more recent challenges facing that model we had been talking about, the Big Bang model. And as we do that, we're going to see that it's not just the light problem is not just a problem for a biblical cosmology. The light problem is a problem for the Big Bang as well. And that's relevant because this issue is usually just posed as something that creationists have to deal with. So look at page 9, flip over to page 9 on the cosmology notes there, and let's take a look together at what I began describing last week. Just a few years ago, there was an opinion piece published on the blog of a well-respected publisher, the Scientific American. And the article was titled, as you see on the screen there, Cosmology Has Some Big Problems. And it highlights some fundamental problems with the current prevailing model of cosmology. And as we've already seen, Big Bang cosmology has had problems in the past, right? When it was first introduced, it faced opposition because of the theistic implications that it carried and that were unmistakable. So it's not unusual. You can do a search and you'll find, this is Scientific American as well, a different article from more recently. A possible crisis in the cosmos could lead to a new understanding of the universe. So it's nothing new for us to hear or see articles touting some new discovery that threatens to upend our understanding of the universe because, after all, shocking headlines sell subscriptions. And scientific publications are under the same pressure as any other publication to have subscribers, otherwise they have nothing to publish. But there really does seem to be a trend in that regard with regard to Big Bang cosmology. And so why is it any different now? Why is this a problem when Big Bang cosmology has faced its opposition in the past? Well, ironically, the current critique focuses on the adherents of the Big Bang's theory's resistance to reevaluating the assumptions that drove them to adopt the theory in the first place. So Big Bang theory comes on the scene. It's opposed by people who don't want to let go of the theory before that. Now the Big Bang is kind of in a crisis, needing either some serious revision, or some scientists are actually saying, let's throw it out and start over. And the folks who hold this are having a hard time letting go of the old theory and evaluating the new evidence. So the people who are saying that this is a problem, the scientists who are saying there's a big problem here, are saying we've got new evidence. We continue to learn things, and the challenge we need to face is that the Big Bang is really, now we're learning kind of a nice story that we've pieced together, but we really just have a lot of these dots, and we thought we connected them very well. But as we're learning more, we're finding out the story doesn't quite add up. So the issues are the same challenges frequently made by young Earth creationists, but which are dismissed simply on the basis that it's a young Earth creationist making the objection. Creationists frequently point out that the Big Bang cosmology is founded on important core principles, the evidence that we all recognize, like the redshift thing that we talked about, the cosmic microwave background. But the foundational assumptions behind the theory and much of the connective tissue, those lines connecting the dots, is more narrative than observation, and more narrative than ongoing discoveries. And the article says this, and that's what I've got there in that quote for you. The author says, born out of a cosmic explosion 13.8 billion years ago, the universe rapidly inflated and then cooled, and it's expanding at an increasing rate and mostly made up of unknown dark matter and energy, right? There's the narrative. And he says this well-known story is usually taken as self-evident and scientific fact. despite the relative lack of empirical evidence, and despite a steady crop of discrepancies arising with the observations in the distant universe. So he goes on and he lists numerous examples of discrepancies, such as major differences in measurements of the Hubble constant. I didn't put the article up here, but there was another article that called the Hubble constant. I mentioned it in several contexts, originally as a fudge factor that Einstein came up with to try to maintain a static universe. And then eventually now it's the way we understand the expansion rate of the universe. And this article said that the Hubble constant is one of the most embarrassing factors in all of science because it's constantly kind of playing a thorn in the side of the various theories of trying to understand our universe and how it came to be and how it's developing. So he goes on and he lists major differences in that, measurements of that. I told you last week with the illustration of the dart throwing from Earth how finely tuned that is, and then there's also some disagreement about what that precision is, but that it is finely tuned. The article explains that dark matter is essentially a concept that was contrived as a placeholder to help make the math work. That sounds familiar, right? Kind of like the cosmological constant. As cosmologists have further developed the theory and grappled with the new discoveries, they've added another placeholder that they call dark energy. And as far as science is concerned, it's possible that the effects that they're trying to explain when they label something dark matter or they label something dark energy, it's possible that those effects really do correspond to something real out there. I mentioned last week black holes were kind of like that. When we first discovered this concept, started formulating what this is, we were just seeing something weird in the sky and trying to explain its properties. And we've got more and accumulating now observable evidence of black holes in our universe. And so maybe these are like that. Maybe they're seeing something, an effect, they're trying to explain it, or maybe the effect they're seeing actually means the model's broken. And that's what this author is saying. He goes on and writes there, I think this quote's on page 10, that's where I left off last week at the top of page 10. He says, it's perhaps worth stopping to ask why astrophysicists hypothesize dark matter to be everywhere in the universe. The answer lies in a peculiar feature of cosmological physics that's not often remarked. For a crucial function of these theories, such as dark matter, dark energy, and inflation, we talked about that last week. It's the concept that we don't really have evidence of. We don't really have a mechanism to explain how it would have happened. But they believe that seconds after the Big Bang, there was this exponential growth in the size of the universe, faster than the speed of light. And it actually goes against physics that this would happen. But it had to have happened, they say, because otherwise the universe would not have been able to have matter coalesce, and we wouldn't have been able to have planets and stars and all of those things. So inflation's important. We don't have any evidence of it. In fact, it kind of doesn't fit, but it had to happen for the model. And he goes on to say that. He says, each of these in its own way is tied to the Big Bang paradigm. It's not to describe known empirical phenomenon, but rather to maintain the mathematical coherence of the framework itself while accounting for discrepant observations. So it's not explaining an observation, it's actually explaining discrepancies in the observation. But it's an attempt to hold the model together. He finishes off there saying, fundamentally, they are names for something that must exist insofar as the framework is assumed to be universally valid. If the theory's right, these have to be a thing. And so that's what he's saying. The Big Bang cosmology is an idea that scientists have developed in their effort to connect the dots between the various pieces of evidence that they're finding. It turned out to be a very useful theory in many ways, not the least of which, in my opinion, is to shift our model of the universe from one that's eternal to one that has a beginning. I think that's a great development. However, because it's been so useful, cosmologists have resisted the growing signs that a new model is needed as new evidence is discovered. And as you see from the article, that's changing. So He goes on to say, after spending many years researching the foundations of cosmological physics from a philosophical and science perspective, I have not been surprised to hear some scientists openly talk about a crisis in cosmology. In the big inflation debate in the Scientific American a few years ago, a key piece of the Big Bang paradigm was criticized by one of the theory's original proponents for having become, he called it, an indefensible scientific theory, or indefensible as a scientific theory. So instead of revising or abandoning the model for a better one, scientists have been positing a number of placeholders to help maintain the math in their models. And to be fair, like I said earlier, that's how science often works. Black holes are an example of that. Nevertheless, things like dark matter, dark energy, and inflation begin to sound strikingly like Einstein's cosmological constant. And that's especially true as theories that do not require the invention of those kinds of placeholders arise. And so the article ends with a summary of the Big Bang cosmology that should disarm the criticism with which any of its adherents may be tempted to level at a creationist commitment to finding a theory that works from within our own worldview. He says the crux of today's cosmological paradigm is that in order to maintain a mathematically unified theory valid for the entire universe, we must accept that 95% of our cosmos is furnished by completely unknown elements and forces for which we have no empirical evidence. For a scientist to be confident of this picture requires an exceptional faith in the power of mathematical unification. So he's saying, all right, these guys really believe in their model. And I get it. I really believe in the model the Bible presents. And I go through all of this, I rehearse all of this to show you that this is how science works. We are, and I'll talk about this more, but we are humans doing science. It's not done, ironically, in a laboratory vacuum. There are all kinds of factors that weigh in on it. So I think we're on page 11, the mystery of starlight then. So let's talk about this. As we noted at the beginning of this section, one of the most common objections to a biblical cosmology or a biblical account of creation in general is the question of evidence for deep time. This takes the form of a question, usually something about how do we see distant starlight in a young Earth creationist model. And to summarize it, if you assume a young age for the Earth, thousands of years, not billions of years, how is it possible for us to see light originating from distances that are more than 6,000 light years away? So light year is not a measurement of time. It's a measurement of distance. It's the amount of distance that light will travel at the known speed, or let me say known speed of light. We're going to talk about that in a year. It takes light a year to go that distance, a light year. Well, we see things in the sky that we have pretty high confidence. Creationists and naturalists alike have pretty high confidence that some of the things we're looking out in space at are way more than 6,000 light years away. They're billions of light years away. So how is that possible then? And creationists have proposed different theories over the years for this. Popular theories you might have heard of. I've got some listed here. One called the day-age theory. It's more of a textual theory, seeing the universe as old, and that each of the days listed in Genesis as creation were actually describing long epochs of time, long ages. There was a theory, the appearance of age, and then one called C decay rate. That C is the variable that scientists use to represent the speed of light. So C decay would be a change in the speed of light, that it's slower now than it used to be in the past. And before I address these and even more current theories, I want to note that the Big Bang cosmology has, as I said earlier, its own light problem. It's called the horizon problem, and I want to talk about that for just a minute here. In Big Bang cosmology, the horizon problem describes the model's inability to explain one of the pieces of evidence that originally led to the development of the theory in the first place. So there's this uniform cosmic microwave background. This is kind of a map that scientists use of that as they look at the known universe, and that even temperature that we mentioned just above 0 degrees Kelvin, 2.7 degrees above absolute zero. And the simplified description of this problem is that the Big Bang model posits that the early universe must have been lumpy. That was what I was talking about earlier. This is the reason inflation was necessary. It had to be lumpy rather than evenly distributed, so kind of thin in one place and lumpy and concentrated in another place. And that was necessary for matter to begin forming stars and planets. And the temperature couldn't been homogeneous over the whole thing. The unevenness of the expanding universe after the Big Bang would prevent some regions of the universe from ever being in contact with others. So you've got this universe, has to be uneven in the beginning, and it begins rapidly expanding. And that means the matter over on this side of the universe never comes in contact with the matter over on this side of the universe. My presentation did that same thing that it did in the past. So I'm going to try get in here one more time, and if not, I'll just go to the notes. Let's see. I had a great diagram of what I was just describing to you, so I want to make sure I can show that to you. There we go. There it is, perfect. So this is the concept here, and this diagram adapted from one that was provided by the Creation Ministries International. We see the cosmic microwave background. I think you can see it on there. Soon after the Big Bang, 13.8 billion years ago, and this means that the 2 points on either side of this huge circle, they're 27.6 billion light years apart. But the microwave background, which is light, it's microwave radiation, that's light, began when the universe was much younger, only, they say, 380,000 years. That's when they say that the inflation stops. So inflation started just a fraction of a second after the Big Bang, and then it stopped at 380,000 years. And that means light that was on one area in one of those circles, the little circle, would have never reached the matter or light on the other circle. So the 2 points could have never transferred energy between them because their circles don't overlap. And so in 1981, Alan Guth proposed the idea of inflation to solve the problem that was known as the horizon or the flatness problem. Inflation, as I mentioned earlier, just posits that very soon after the Big Bang, the universe went rapid expansion. Despite its wide acceptance, inflation theory has zero observable evidence. And we saw in that article, inflation is the specific part of this that they were calling an indefensible as a scientific theory from one of the original proponents of the Big Bang theory. Another recent solution offered to explain why there would have been equilibrium in temperature in the cosmic microwave background, the light, across the entire universe, in spite of there not being enough time, even with 13.8 billion years age of the universe, in the theory proposed for that to be able to equalize, since the radiation travels at the speed of light, is, get this, so the theory that creationists came up with to try and explain how do we see those things so far away, they're way out there. How can I see those if they're 13.8 billion years light years away and the universe is only 6,000 years old? How can I see those? Well, we had this idea of maybe light traveled faster in the past. Lo and behold, scientists are saying maybe light traveled faster in the past to explain how this evenness of temperature happened in the Big Bang. They say that the speed of light was possibly much faster in the past, maybe up to 10 times faster. Creationists don't tend to believe this anymore, so we'll see as we learn more how that pans out. But the problem of distant starlight is a problem for the naturalist as well as the creationist. And just like naturalists, creationists have proposed theories to solve this. So let's talk about creationist solutions to the light problem, and that's on page 12 in those notes that you've got. One way that some creationists have tried to answer this problem is to interpret the Genesis account such that the days of creation are not normal days as we would understand them to be, and that's what I referred to as the gap theory, or the day-age theory. And that's really more a textual theory, and so I'm not going to deal with that here. We're not going to cover that. Maybe in another section, if we have ever occasion to go back on this theory, we could talk about the textual questions there. But just sticking to the scientific theories, another theory that creationists have explored is a concept commonly referred to appearance of age. And so here's the reasoning with the appearance of age theory. Just as God created Adam and Eve as adult humans and trees with their fruit on them in the garden, perhaps he created stars with their light in transit to earth so that they could be seen from earth the moment that they were created. And this was a very appealing theory to me as I was a young believer and started learning about some of this, and very early on in some of my testimony that I shared at the beginning of the series. I thought that makes a lot of sense. I didn't understand. I heard some folks, creationists, make objections to it, and I didn't really get them for a long time, but I tried to boil it down, make it simple. Maybe you'll get it quicker than I did. The problem with this theory is that, in a very real sense, light carries data or information. You know, I would hear somebody, a creationist, say, well, that would make God a liar, and I don't understand what you're talking about. Was the fact that he created Adam as a grown man lying? No, it's not. And so, while it's not problematic or deceptive for God to create a human or a tree that is, and I love this term, this is very helpful, the folks at Creation Ministries International, they try not to use the appearance of age term. They rather refer to it as functionally mature. So to create Adam as a functionally mature man is a very different thing than for God to create the appearance of like a supernova, which is really a visual story of a star exploding, and for God to create that when this never really happened. For example, as you see in footnote number 13, there's a supernova, SN 1987A. It's called that because 1987 is when we observed it. It was a Type 2 supernova 168,000 light years away from Earth in a dwarf satellite galaxy of our own, or a dwarf satellite galaxy of our own galaxy, the Milky Way. Light from this explosion reached us on February 23rd, 1987, and its brightness peaked on May of that year. It was the closest observed supernova since Kepler's supernova in 1604, and it was the first supernova that modern astronomers were able to study in great detail. So you can see in the pictures there, they're tracking this for years, the progress of this. It's telling a story of what happened to that star so far away from us. And if we were to take the theory that, well, God just created this with the light already here at us, we're saying that, well, God created this fake story that didn't really happen, and that's what we're watching play out now. So it doesn't really make sense either by what we know of God from his revelation or from the scientific evidence that we're discussing. So if God created the appearance of this star exploding that never actually happened, it would seem that God was creating something deceiving. And so for that reason, our friends at creation.com included in their list of arguments they recommend creationists not use. So it's worth noting here that while God's word does not change, our understanding of our world through scientific study is constantly changing. I say that over and over. And that's important for us to remember because we can discard theories that don't work. We can say that that theory doesn't make sense, and so we're going to abandon it, even though maybe it was helpful in trying to see how things fit into a biblical worldview. Is something going on? Is somebody on the computer back there hitting something? It keeps changing on me. No? I'm going to relaunch it on here and see if that fixes it. All right. So there have been at least, I'm gonna skip ahead to get to the creationist models. The latest current models, there have been at least 4 explanations of how cosmological models or explanations of how do we see this distant starlight in a young creation. And they agree with a normal reading of Genesis. They don't require dark matter. They don't require dark energy. They don't require some arbitrary inflation in order to cohere. And there's a great discussion of these models by Dr. Robert Carter, who was here with us recently, and Dr. Jonathan Sarfati, who was with us a few years ago. And we've had them both here. They have a video discussing this very concept, and they mention these four, and I'll just highlight a few of them. One of them in particular I want to accentuate for you. I think it's a great explanation. There's one known as the Setterfield hypothesis. We talked about this earlier as C decay. So this is the idea that the speed of light was faster in the past than it is today, and that would explain how light from stars so far away could reach us in a shorter amount of time. And creationists, as I said, don't talk about this much anymore. Most creationists have concluded that while that might be true, they haven't said that no, that can't be light. The speed of light can't change. It does carry with it the change in the speed of light, and this is beyond my pay grade and probably most of yours. But physicists say that the speed of light changing has serious implications in physics. It affects other things in physics because the speed of light is like a constant that everything else is measured by. Even time, we'll get into that. But most creationists have concluded that while it might be the case that the speed of light has decreased over time, it doesn't really ultimately solve the problem. So most creationists have said that's probably not the best answer. The next one is what I've called white hole cosmology. And let's see, we're on page 13 in the middle there if you're following along in the notes. This is a theory proposed by Dr. Russell Humphreys in the mid-90s, and it still holds a great deal of explanatory power. By the way, Dr. Humphreys is a retired research physicist. He has patents on multiple thermal couple switches that he's designed. He's a former scientist that worked for Creation Ministries International that Dr. Carter is from. And he predicted the strengths of magnetic fields of the planets of Uranus and Neptune before NASA's probes got there. This was amazing to me. Just goes to Dr. Humphreys' credentials. NASA had made a prediction of what the magnetic field of Uranus would be. And when they got there, they discovered that they were off by a factor of 1 million. But guess who got it right? Dr. Humphreys got it right. And the reason his prediction was correct, he says, was because he based it on assumptions about how the planets were formed from a biblical worldview and how long ago they were formed, how long it would take for their magnetic fields to weaken. So he wrote a book on this problem of starlight called Starlight in Time. It's a small book, and I recommend it. You might not be able to get it new. I don't remember if it's in print or not. But the first 2 chapters are actually a great layperson's explanation of his solution to this. And then he has several appendices in the back where he goes into all the math and the details. But you could read the first couple chapters and probably get it, but I'll give you a synopsis of it. In that book, he provides a relatively easy to digest overview of the theory. And as we learn more about the implications of Einstein's general relativity and quantum mechanics, his theory just gains more credibility. So essentially, he proposes that the sequence of events described in the first 3 chapters, or the first 3 days of the creation week of Genesis 1, are describing what it would be like if God created the entire universe beginning with a black hole. Initially compressed into that small space of a singularity of a black hole where there's no time. Sounds a lot like some of the things that the Big Bang cosmology were identifying when they started forming that theory. And by the way, this is an artist's depiction of a black hole. We recently did, through a massive effort on the part of lots of people in the field of science, capture an actual image of a black hole. It looked more like this. This is M87, an actual black hole that scientists have been studying. But Dr. Humphreys' theory proposes that perhaps God created the entire universe initially compressed into a black hole where there is no time because of gravity and what's called gravitational time dilation. And then as God continued his creative work, running what we think of as a black hole backwards and spreading out the universe, as the Bible says that he spreads out the heavens, it would become what cosmologists have theorized as a white hole. And so you can see the kind of the opposite features, a black hole of a white hole. Just as nothing, not even light, can escape from a black hole, nothing, not even light, can enter a white hole. So as God's stretching out the heavens, time, the flow of time would be incredibly fast on the outside of the event horizon. When I say incredibly fast, if you were outside of it, it wouldn't feel incredibly fast. It would just feel like time, because time is relative to the observer. But relative to the surface of this planet, which would still be inside the event horizon, time would seem incredibly fast out there. If you had a telescope and you could see what was going on outside of it, which you couldn't because the light problem, but it would just look like things are a blur. So as God stretches out the heavens, time would flow incredibly fast on the outside of the event horizon relative to hardly any time at all passing on Earth, as it is still inside of the event horizon. But then as Earth crests the event horizon on day 4 of creation week, all of the stars would immediately become visible to Earth. And this scenario accounts for the light of stars at vast distances from Earth having enough time to reach Earth while maintaining the very real, normal passage of time on Earth as described in Genesis, which is written from Earth's perspective. And I want to stop right there. You might be thinking, well, this has the similar problem to the appearance of age. And I say I want to stop. I might actually have this written in here. I can't remember how much I put of my speaking notes in the written notes there. But at first blush, you might say, well, this is deceptive. It's the appearance of age. But it's not, actually, because of how time works. We could easily spend an entire session talking about the theory of relativity or actual experimental observation evidence proven to us over and over again that time is relative. But I'll explain it really simply as I can. Time dilation is a concept or a phenomenon where time passes differently for observers in different frames of reference. So, especially if there's relative motion, so one observer is traveling at a different rate than the other traveler, or there's a difference in gravitational potential. So gravity's stronger from one point of observation than it is on the other. So, for example, clocks on a rocket are used to demonstrate this. Imagine 2 identical clocks, one on Earth and one on a rocket, traveling at a significant fraction of the speed of light. So it's moving, not quite the speed of light, but almost. According to relativity, the clock on the moving rocket would appear to tick slower than the clock on Earth when observed from someone on Earth. I think I got that backwards. The clock on the rocket would appear to tick faster. Yes, that's why this is difficult, because they're relative. The person on the rocket next to the clock would think everything's normal. But if you could see them from Earth, you'd be like, wow, that's a fan, not a clock. It's just shh, because of the speed. Clocks also at different altitudes track time differently, or the flow of time. They show us that the flow of time is experienced differently. A clock at a higher altitude where there is a weaker gravitational field would appear to tick faster than a clock at a lower altitude, stronger gravitational field, as predicted by general relativity. And as I said earlier, this isn't merely theoretical. We know this. We watch this. You actually see this every day and you don't know it. And here's how you see this every day. Because gravity affects GPS satellites in a way that requires corrections based on Einstein's theory of general relativity. Because of time dilation, due to the weaker gravitational force at their altitude, clocks on GPS satellites run faster than clocks on Earth. And so this effect is predicted by relativity. It causes clocks on satellites to gain about 45 microseconds per day. The speed of the satellite also affects it. Special relativity predicts that the satellite's motion causes the clock to lose about 7 microseconds per day. So the net effect, combining both effects, is that clocks on GPS satellites run approximately 38 microseconds faster per day than your clock here on Earth. And so they actually adjust the clocks on the satellites so that your GPS would be accurate. It'd be about 3 days and your GPS wouldn't make any sense to you if they didn't do this. If these relativistic effects were not accounted for, GPS units would lose their accuracy very quickly. This keeps dropping out on me, so I'll keep talking as we talk about that. So this is a fascinating theory that is not just based on, well, maybe God could have done it this way. This is based on something that we actually see in observational science. We don't have to invent dark matter. We don't have to invent any inflation theories to make sense of this. That's the theory of white hole cosmology, in which a sequence of events described in the first 3 days of creation that we read in Genesis 1 are describing what it would be like if God created the entire universe, initially compressed into a black hole where there's no time. And then, as he says, and let there be stars in the sky, if you were standing here on Earth, the moment he said it, and Earth crests the event horizon of that massive body in space, we would see the starlight. Then as God continues his creative work, running what we think of as a black hole backwards, everything proceeds just as I had mentioned it. As God stretches out the heavens, time would flow incredibly fast on the outside and slower on Earth by relation, or relatively speaking. And that explains all of the things that we see in Genesis. It explains the evidence that we see around us, and in a way that they harmonize. So a third theory, moving to bottom of page 13, and I just spent more time on that second one just because I find that compelling. Probably I've read more about it because I find it compelling, but we don't know for sure that that's the answer, but that could be. Cosmological, you see at the bottom of page 13, cosmological or Carmelian special relativity. This is a theory used to explain galactic rotational curve in the expansion of the universe without having to resort to something like dark matter and dark energy. This is a theory championed by a scientist by the name of Carmeli. He was a mathematician and a physicist who contributed significantly to the development and understanding of special and cosmological relativity. And his work explored the mathematical and conceptual foundations of the theory. He provided the framework that applies the principles of special relativity, so all that time stuff we were talking about, to the large-scale structure of the universe. So if that gravity and velocity effects on time are true, how does that affect the overall universe, this whole Big Bang model? So he developed and fleshed out a lot of that. Part of the claim to fame for him is there's a big problem in cosmology that says, all right, so if the universe is as old as we think it is, and galaxies form the way we think they do, they should be spinning a lot slower on the outside of the galaxy. Well, the things that he developed with this, what's been named after him, Carmelian relativity, says, well, this is why it works that way. And he's able to explain this using gravity and some of these other relativity theories that we talked about to explain why galaxies aren't rotating the way scientists would expect them to if their model were correct. So as we saw earlier, Einstein's special relativity deals with the relationship between space, time, speed of light, and a static, unchanging universe. And in contrast, this theory just recognizes that the universe isn't static, it's expanding, and the expansion affects how we perceive space and time at a cosmological scale. And I just want to point out, this isn't a creationist theory, though a lot of creationists think it might be the key to understanding this problem of distant starlight. Carmeli was not a creationist, wasn't a Christian, I don't even think. But some creationist scientists have explored this model and what they call, and I read enough of it to repeat it here back to you, but this is one of those that's above our pay grade, I think. This model within a 5-dimensional framework. So 4-dimensional would be the things you normally think of: height, width, depth, time. Over time, that's the 4th dimension. A 5th dimensional would be another dimension. Talking about 4 dimensions bends my mind a little. 5, I'm going to take their word for it. But these non-believers and believers alike are suggesting that explanation of the universe, that it occurred in a short period during the creation week and has remained stable ever since, could explain what we see around us, including distant starlight. And then there's a 4th theory, the asynchronous time theory. Oh, I just noticed the time we're at, and I've got to... Yeah, I can finish this. This is a solution proposed by Dr. Jason Lisle. Essentially, it acknowledges that we have no way to measure light in a one-way trip. We always measure the speed of light in a round trip since it's impossible to truly synchronize two clocks that are in different locations. The instant you move one clock, they're no longer synchronized because gravity and velocity affect the flow of time. Dr. Lisle proposed that the possibility that the speed of light is not the same in both directions. And in other words, it's possible that light travels at a different speed when it's going away from you than when it's coming toward you. Maybe it travels at half of what we think of the speed of light when it's going away, and it's instantly when it's coming toward you. And that sounds like, yeah, good job, creationist. You thought of a way to explain this. That's totally absurd. That's ridiculous. If this were true about light, then, we'd be able to discover, well, no, not actually. While this might sound like, to somebody who doesn't know this subject matter, as a stab in the dark by creationists, it's a very technical concept, and a lot of scientists are actually interested in this. So I'm going to play a video clip to finish off here for you today from a channel called Veritasium. Very popular, very credible YouTube channel that's been around for over a decade. And go ahead and hit play on that for me, guys, because this dropped out on me
Can
again.
fire a beam through a perfect vacuum for 1 kilometer. You have a laser that can fire a beam through a perfect vacuum for 1 kilometer. Start a timer the instant you fire the laser beam, and then exactly when it hits the end, stop the clock. Except, how do you know when light reaches 1 kilometer if you and the clock are at the starting point? Okay, so you need 2 clocks, one at the laser and one at the end, which stops automatically when it detects the laser light. But now, how do you make sure your 2 clocks are synchronized? Well, you could connect them via a wire and send a pulse from one to the other, but that pulse will travel at the speed of light, so it will arrive with a time delay. You might think you can just subtract that time delay, but it is equal to the time it takes for light to travel 1 kilometer. That's what we don't know and are trying to measure. Okay, new plan. Start with the clocks together and sync them up first, and then send one of the clocks down to the end. Now, what could possibly go wrong? Well, I'll tell you. The clock at the finish line was moving with respect to the one at the start, and special relativity tells us moving clocks tick slow relative to stationary observers. So by the time the clock reaches 1 kilometer, it will no longer be in sync with the clock at the start. Can I tell you the only solution to this problem? Ditch the second clock. Put a mirror at the end to reflect the light back, and use a single clock at the start to time the full 2 kilometer round trip.
Wasn't this actually done before? He was on a mountain, and there's a wagon wheel with a lantern, and there's something like a mirror on the other side of the mountain. I've always wanted to do this.
So, that sounds a little like how the speed of light was first experimentally measured by Hippolyte Fizeau in 1849. He shone a beam of light between the teeth of a rapidly spinning gear to a mirror up on a hill 8 kilometers away. And then by increasing the speed of the gear, he reached a point where the reflected light passed through the next gap on the gear, and so it was observed. So he measured the speed of light to be 313,000 kilometers per second, which is within 5% of the presently accepted value. So someone has measured the speed of light. Or have they? What has been measured is the round trip or two-way speed of light, but no one has measured the one-way speed of light. One thing I'm going to throw at you, and I'm just going to come out and tell you. It's like, what if the speed of light in this direction is different from the speed of light in this direction?
Then that sounds like a Veritasium video.
The question is, could you figure it out? The kind of crux of this problem is that the only way people have managed to measure the speed of light is for a round trip. No one's ever managed to measure the speed of light in just one direction. It's possible that the speed of light is half of c in one direction and then instantaneous on the return journey.
What?
That's possible.
Are you serious?
All right, so This is not just a creationist theory trying to explain something. So Veritasium, don't believe that gentleman who runs that channel is a Christian. Now the guy from the other guy, he runs a channel called Smarter Every Day, and I'm pretty sure he's a Christian. He doesn't make his channel, it's about science, but his testimony, he's said things that make me think he's probably a Christian. But this is not a Christian theory, but Dr. Jason Lisle probably frequently gets dismissed in the mainstream because you're just trying to explain your Bible. No, he's trying to look at the evidence. And so which of these theories is correct, we're not sure, but we can be sure that we are still learning and we have much more to learn. And you can be sure that the biblical account of Genesis has not been shown to be incorrect. When we start with that account, we find a wealth of explanatory options available to us as we explore this amazing universe that God's created. All right, we're through cosmology. We will begin with geology next week. Let's pray quickly as we're finished. Lord, thank you for this opportunity to look at the marvels you have created. Help us to submit ourselves to you as we pursue understanding. We pray in Jesus' name. Amen. All right, thank you.